Tendulkar greets him by dancing down the track and hammering it.
Hello friends, today we have a very interesting problem. Today's problem is about Sachin Tendulkar and his six hitting. Everybody knows about Sachin Tendulkar, and so Sachin Tendulkar takes on Shane Warne. If you guys don't know who is Shane Warne, he was a legendary spinner, and there was a big contest between Sachin Tendulkar and Shane Warne. One of such contests was 1998 at Sharjah, Desert Storm innings it was called, and that was a magnificent innings by Sachin Tendulkar. And so I have tried to design a problem, a real life problem that will help you appreciate the physics you are learning at the textbook level, so that when you watch sports or do something else in the real life, you will be able to apply them mentally. Okay, let's read out the problem. Sachin Tendulkar takes on Shane Warne and hits him for a 6 over mid-on at Sharjah. Sharjah is the name of the ground. The boundary is located 70 meters far from Sachin and the ball goes for 6. Just clear of Jason Gillespie standing on the boundary rope, jumping up to attempt for a catch. If Gillespie had jumped up to reach 2.5 meters above the ground, then find the speed with which the ball left the bat after striking and the distance of the 6. Angle of initial velocity is given as 60 degrees. Assume no air friction. And G is given as 9.8 meter per second. So we have been given the angle of initial velocity, that is 60 degrees, and it is told that just at the boundary rope Jason Gillespie is standing. Let's try to visualize the problem. Here Sachin is standing. Here Sachin is hitting the ball and the ball is traveling all the way towards the boundary. Let's say this is the boundary point, and here Jason Gillespie is standing. Jason Gillespie was a very tall bowler, fast bowler. Those who likes to watch highlights will know that he was a very good bowler in the Australian bowling lineup, and he was a tall bowler, or almost more than 6 foot 2 inches taller. So he's jumping up to catch the ball. He was almost there, but the ball goes just clear of Gillespie. That means Gillespie was almost there, but he was unable to catch it, and then it goes for a 6. So Gillespie was standing just over the boundary rope, let's assume. Now our question is to find the initial velocity, that is the magnitude of initial velocity, that is speed, and the total range of the projectile. Why the range? Because we are asked to calculate the distance of the 6, that means where the ball actually hits the ground. Okay, so now this question is not that difficult, although after looking at the question you may feel that it is a very complicated question, but not at all. And we have been told to neglect air friction, and the ball is launched from the ground level. So it's not the case that the ball is launched say half meter from the ground. No, it is launched from the ground level. Okay, see, I have drawn it here exactly. Here Jason Gillespie is jumping, and this height is 2.5 meter as given. This height is 2.5 meter and Jason Gillespie is jumping, and the boundary rope is situated at 70 meter, and here I have shown this full range as R, and G is given as 9.8 meter per second. Now we have been given a point, that is when x is equal to 70 meter, we have corresponding y is equal to 2.5 meter. When x is equal to 70 meter, y is equal to 2.5 meter. And we are asked to find out the range and the u, initial velocity. The best solution or the quickest solution, we can do it from the equation of trajectory. That means we'll just write the equation of y with respect to x, that is the variation of the height with respect to the displacement in the x direction, and then we'll just plug in the values. So the equation of trajectory is y is equal to x tan theta minus half g x squared by 2 u square cos square theta, where theta is equal to 60 degree and g is 9.8 meter per second, and y is equal to root 3x, because tan theta is equal to root 3 and theta is equal to 60 degree. So y is equal to root 3x minus half into 9.8 x squared by u square cos square 60 degree. Cos square 60 degree is equal to 1 by 2 whole square 1 by 4. So 1 by 4 here. So 4 and 2 cancels and denominator is 1 by 2. So finally it comes out to be y is equal to root 3x minus 19.6 x squared by u square, where u is the initial velocity. Here u is unknown. Here I can say that u is unknown. Now at x is equal to 70 meter, y is equal to 2.5 meter. We can see this here. When x is equal to at this point, when x is equal to 70 meter here and y is equal to 2.5 meters, so I can say that this point, let's say 70 comma 2.5, this lies on the trajectory, equation of the trajectory. This lies on the equation of the projectile, that is the equation of the parabola we're getting. So we are just putting this equation in this, putting the values in this equation, that y is equal to 2.5 and we are putting the value of x as 70 and here 70 square. So we have to find the unknown u square. After solving, u is coming out to be here 28.439 meter per second. 28.439 meter per second. You can solve it. Very simple calculation. And what is the range? The range will come out, just put the formula u square sine 2 theta by g, that is u is, we have calculated the value of u as 28.439 meter per second. So we'll square it, and sine 2 theta, theta is 60 degree, so sine 120 degree by 9.8. So it is 71.473 meter. So we can imagine that 6 was not a flat 6 but a high air 6. That means Sachin is hitting it at 60 degree and it is going high up in the air, and it just clears the boundary by 1 meter only. And Jason Gillespie tries his best by jumping up. He's a tall man and he jumps up to catch the ball, but he is unable to catch the ball. It just clears him. So I hope you liked the example, and definitely it will add interest to your it will make you build the interest in the subject. And if you like this question, if you like our idea to provide interest to you, then please like this video and share this video with your friends, and please subscribe our channel. So thank you, and stay tuned for more such interesting videos.